Here we look some more at conductors in electrostatic equilibrium. The figure at right represents a solid conductor in electrostatic equilibrium. It has a net positive charge. Letter A, draw several positive signs into the figure to show how the charge is distributed on the conductor's surface. Areas where the radius of curvature is small, charge is going to be built up. And where the radius of curvature is large, the charge is going to be spread out. Something like that. If we were to draw electric field lines in here, electric field lines go away from positives and toward negatives. So the electric field lines are going to be spaced quite closely here at the right side of this, but then they're going to be spaced much further apart for the rest of this conductor, something like that. We could draw more electric field lines if we wanted, but the point would be that over here on the right side, those field lines should be very closely spaced. And out here, the electric field is weaker. If I draw a little e right there, that kind of indicates that the electric field is weaker there. Let's review. On the inside of the conductor, the electric field is 0, and the electric potential V is a constant, some constant number of volts. This whole conductor we might call an equipotential volume. What if the conductor is placed in a uniform electric field directed from left to right? Let's draw the charges on the conductor and the electric field lines that represent this situation. If we had an electric field directed from the left to the right, let's say there's a field line right there, and there's a field line right there. The mobile electrons in here are going to want to go opposite that electric field. There's going to be a buildup of negative charge on that side of the conductor, and these field lines are going to terminate on that edge, something like that. But this conductor still has a net positive charge, and I believe I drew 7 positives in the first drawing. So what that means is I need to have a net plus 7 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That will still give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That still gives me my net positive 7, which is what we had in our first drawing, if we want to be consistent. And so what that means is we're going to have electric field lines that are going to go away from this, something like that. There are going to be more field lines that are going away from this than there are field lines that are terminating on it, because it has a net positive charge. If it's neutral, then we're going to get a situation where the incoming field lines terminate on this side of the conductor, and the exact same number of those field lines is going to be originating over here and being directed to the right. But we have more originating on the right side here because this conductor has a net positive charge. Inside, the electric field is still 0, and the potential is a constant. Some number of volts, but it's a constant.